In this video, we're going to evaluate the limit as x approaches 5 of the function 3 times the square root of x minus 5. In order for this overall limit to exist, the y value that we approach must be independent of the path that we choose. And we have two possible paths that we can choose as we get closer and closer to 5. We can approach 5 from the right-sided direction, or we can approach 5 from the left-sided direction. So let's evaluate these two one-sided limits and see what's happening. For our right-sided limit, we're going to go ahead and start evaluating on our calculator using some values that are in the neighborhood of 5, but a little bit larger than 5. So I'm going to start with inputting 5.1 into our function and seeing what we get. Converting this into a decimal number, we get about 0.948. Let's go ahead and choose a value a little bit closer to 5, like 5.01. Go ahead and evaluate that, and we get 0.3. And as we increase the number of zeros here, we are going to notice that the values that we're getting in return are getting closer and closer to 0. So this right-sided limit is approaching a y value of 0 as we get closer to 5 from that direction. Let's go ahead and start to work with our second limit. So we're going to try to approach 5, but from the left side of 5, or values a little bit less than 5. So let's try beginning with something like 4.9 and see what happens. And I do get an error on my calculator. That's because 4.9 take away 5 is a negative value, and I cannot have a negative value inside of the square root symbol, at least for real numbers. So what does this tell us? This tells us that for values a little bit lower than 5, this limit actually does not exist. It's not possible to find a y value where my limit is tending towards because the function doesn't even exist on that side of 5. Now, this allows us to conclude that the overall limit as x approaches 5 will not exist. It has a right-sided limit of 0, but because my function doesn't exist on the left side of 5, it doesn't really make sense to talk about the overall limit. So we're going to say that this limit, DNE,